Hello guys, I am Omkar, your physics class teacher, class 12. Today we discuss about the motion in a straight line. First of all, we should know the term of motion. What is the call of motion? Motion, which object position changes with time, that is called motion. Which object position changes with time, that is called motion. See guys, I am here. After 1 second, I am here. First, before the 1 second, I am there. Now I am here. My position was changed with time. That is called motion. This chart is where it is positioned. This is on my palm. This is in rest position. After the 1 second, it goes up to down and down to up. The chalk piece position was changed with time. That is called motion. Object position changes with time. That is called motion. And the term of straight line. Straight line, nothing but one-dimensional motion. What is the meaning of one-dimensional, guys? Object moves either horizontally or vertically. Either horizontally or vertically. That is called one-dimension motion or rectangular motion. This is the basics. And guys, motion we describe with some terms. How we describe the motion? Motion described with some terms. That is distance, displacement, speed, velocity, as well acceleration. Motion describe distance, displacement, and speed and velocity and acceleration. Use these terms, we describe the motion. First of all, what is the distance? What is the distance, guys? Can anybody say? Okay. Let me explain. Distance. Distance, nothing but path length. This is the one object, one point. This is the one position and this is the another position. Position, we generally describe the x. This is the initial position and this is the final position. This is the one path length. This is another path length. These are all the path length. Object travels any distance. Whatever distance the object wants, object travels that path length. This path length is called distance. This path length is called distance. Units. Distance SI units meter per meter and CGS units centimeters. And what is the displacement? Second term. Displacement, shortest distance, shortest path length, nothing but displacement. Shortest distance or shortest path length, that is nothing but displacement. Moreover, final position to initial position, that is called displacement. Change the position. Delta. Delta, we used the term in mathematics, physics, chemistry, used delta. Delta means change. Change the position. Delta X. Change the position. Initial, final minus initial. This is called displacement. Final position, change the object position. Final position to initial position. That is called displacement. SI units same as the speed. SI units meters and CGS units centimeter. This is the distance and displacement, and we should explain and we should take some examples and for the better understanding. This guy travels 3 meters. This position to this position, that position, and another 5 meters he traveled. What is the distance as well displacement? What is the distance and displacement? Distance, see guys, distance. What is the meaning of the distance? Path length. That is called distance. What is this position to this position? How much the path length? 3 meters. As well, what is this position to this position path length? 5 meters. Totally how much? 8 meters is distance. And displacement. Displacement, final minus initial. Final minus initial. How much the final? 8 meters. How much the initial? 0 to start. Start with 0. End with 8 meters. So totally what? 8 meters. So distance is equal to displacement. In this case, distance is equal, we proved distance is equal displacement. And we take another example. Just we take another example. This guy traveled 4 meters and this guy traveled 8 meters, and it takes the U-turn to 6 meters. Okay, what is the distance and displacement. Next, what is the distance, guys? Distance is nothing but path length. Distance 4 plus 8 plus 6. How much? 18 meters. Guys, every physics student must know the units. Units is necessary to physics. Whatever you learn in physics, units is must. So you must be by heart the units. You must be understand the units. Okay. Next, displacement. Displacement. What is the displacement? Final position to initial position. Once you know. 4 plus 8. Take the U-turn. 6. Total how much? 12 minus 6. 12. 6 meters. This is the displacement. What we proved? Distance greater than displacement. We had proved before the problem distance is equal to displacement. So distance greater than or equal displacement. And we take the another example. Distance is a and these terms we learn. Distance is a scalar quantity. After this lesson, we will started the what is the scalar and what is the vector. Displacement is a vector. What is the basic meaning of scalar, guys? Scalar wants to magnitude only. Magnitude. And vector wants magnitude as well direction. And direction. What is the meaning of magnitude, guys? 10 meters. How much the magnitude? 10 is the magnitude. M units we know. Already we learned. 10 is the magnitude. Magnitude, what we understood in this situation? Magnitude is nothing but mathematical value or physical value. That is called magnitude. Displacement is scalar. Scalar only wants magnitude. Vector wants to magnitude as well direction. We know distance, any path length is distance. Shortest path length, final minus initial, that is displacement. We take one example. This is origin. 1, 2, 3, 4, 5. What is the displacement, guys? Displacement, this is the initial, this is the final. What is displacement? Displacement change the object position. That is called displacement. Final position minus initial position. What is the final position? 0.5. And what is the initial position? 2.5. Totally what? Minus 2 meters. This represents direction. Object moves with which direction object moves? This sign represents. So what we understand from this? Displacement wants displacement is a vector quantity. Displacement wants to direction. Displacement have the direction. This symbol represent to direction, minus direction. Sorry, negative direction. And we take some examples. This is the semicircle. R to R. What is the distance and what is the displacement? Distance pi r, because total circle circumference 2 pi r, semicircle circumference pi r, 2 pi r by 2, nothing but pi r. And what is the displacement? Displacement is equal to shortest length r plus r is equal to r. This is closed. And another example. This is the circle. Oh, sorry. Okay. This is the direction. This direction object moves. What is the distance, guys? 2 pi r. What is the displacement? 0. Why? Because of object moves this position to this position. Final position and initial position is same. That's why displacement is 0. Total circumference in a circle 2 pi r. That's why object covers the distance 2 pi r and displacement 0. So what we learn? Displacement is not 0, but displacement may be a 0. Okay? Displacement can be a 0. Displacement can't be 0. Keep it, guys. This point, keep it in your minds. Keep on your notebooks. And we take the another example. AOB. This is 4 meters and this is 3 meters. What is the distance, guys? Distance 4 plus 3 is equal to 7 meters. What is the distance displacement? Pythagoras 3D we applied. 4 square plus 3 square is equal to 16 plus 9 is equal root over 25 is equal 5. So what is the displacement? 5 meters. This is what? Displacement and distance. And we take one example. This is the arc. What is the distance? Arc distance. L is equal r theta. This is the formula. We must know that formula. Arc formula. L is equal r theta. This is the theta angle. Just another method we take. What is the circle circumference? 2 pi r. How much units? 2 pi units. Nothing but 360. How much angle? Theta angle. 2 pi cancel. What remains? R theta. This is what? Distance. And now we calculate the displacement. Displacement. This is a theta by 2 and this is theta by 2. This is R and this is a position X, position X. Sin theta. Sin theta. Actually sin theta, but from this picture sin theta by 2. X by R. So what we would learn? X is equal r sine theta by 2. X plus x, 2x. What? 2r sine theta by 2. Oh, okay. X plus x is equal 2x. One x is equal r sine theta by 2. Another x is equal r sine theta by 2. Totally 2r sine theta by 2. This is what displacement and distance. And what is the speed? Guys, speed nothing but distance by time. This is called speed, units meters per second. And velocity, this is the displacement by time. That is called, so same units, meter per second. Speed nothing but ratio of time and distance, nothing but speed. Ratio of time and displacement, that is nothing but velocity. Units, say SI units, meter per seconds. SI units, meter per seconds. Say SI units, meters per second. Speed and velocity. And what is the uniform velocity, uniform speed and uniform velocity? Which object goes constant speed, maintain the constant speed, that is called uniform speed. Which object maintains the constant velocity, that is called uniform velocity. But you know guys, that is impossible, because of it really that was not a possible, because you might be go somewhere, you might be up and down. Our speed is up and down. Rush area we go slow, and plain area in the highway, during the highway time we go speed, very speed. So our speed not constant, our speed up and down. Rush area we go slow speed, and in the highway we go very fast. So at that time we take the average speed and average velocity. We take the average speed and average velocity. What is the average speed and average velocity? Total distance by total time is average speed. Total distance by total time is average velocity. Once I write, what is the average speed? Average speed, total distance by total time. This is nothing but average speed. Units is same, meter per second. And average velocity. What is the average velocity? Total displacement by total time. Nothing but average velocity. This unit is also same, meter per second. This is the average speed and average velocity. You should keep on your mind, guys. Please note on your notebooks. These are all terms very important irrespective of marks. Okay. Next we take some examples on average speed. and average velocity. This is the one guy covers 3 meter per second. Another time he covers 4 meter per second. Another time he covers 6 meters per second. What is the average speed and average velocity? How much? First of all, what is the average speed? Total distance by total time. Average speed. What is the average speed formula? Total distance by total time. That is called average speed. Average speed. Okay. They give the speed. We know speed is equal to distance by time. So we find out the distance is equal to speed into time. Okay. This is 2 seconds and this is 3 seconds. Okay. Distance. Sorry. Speed 3 meters into 2 seconds. Totally 3 meter per second by 2 seconds. 2 seconds. Totally 6 meter second by second. Totally distance 6 meters. Okay. Next 4 into 3, 12. 12 meters. What is the speed, guys? Average speed? Distance, total distance by total time. 18 by 5 meter per second. This is the average speed. We calculate the average velocity. Now, average velocity formula is displacement by time. Displacement nothing but velocity into time. So, what is the displacement? 6 meters. What is the another displacement is what? 12 meters. Total displacement what? Totally same. Total displacement by total time. This is 18, 12 plus 6 and 2 plus 3 more. Totally 18 by 5 meter per second. This is the average speed and average velocity. What if they take the U-turn in 2 seconds, 3 meter per second? What is the average speed? 6 plus 12 plus 6 to the 18 plus 6, 2 plus 3 plus 2 plus 3. Totally how much? 24 plus 18. Answer. Calculate the answer. In velocity. Velocity is same. 6 plus 12 plus 18 minus 6. by 2 plus 3 plus 2 plus 3. Calculate the answer. This is what speed and velocity. We finished the distance, displacement, speed and velocity. After the after the session, we will complete the acceleration and after some topics. This is our today's section. Bye guys.